Ted, thank you, and congratulations on this. This is really amazing. Filling this room, the technical sessions are extraordinary. I really feel like the industry has arrived in many ways. I don't think I need to be near this. I'm laved up. What I wanted to do is to cast this moment in the arc of history, to let you see what I feel I've been privileged to see is a movement, is a moment in time that looks to me like the dawn of the internet. This is big, and what I hope to tell you over the course of this 40 minutes or so is just how big. In 1972, a guy named Stuart Brand, who was a Silicon Valley thinker, had created the Well, one of the early communities. He was an environmentalist, and he knew that NASA had satellites out there. And as an environmentalist, he wanted to know what does our blue marble look like from space? And so he asked NASA to give us a picture of the whole Earth. And this is it. It was from Apollo 17. And for the first time, we were able to see the planet as a whole. We were able to see its fragility. We were able to see its life. And this led to the Whole Earth Catalog and a movement that really considered the Earth as a whole and allowed us to realize that we were beyond managing pollution locally, but rather the climate globally. And this changed our perspective on the world and launched a movement that was going to do something about the climate. In many ways, it was effective, but there's much more work to be done. That was 1972. I feel like we're doing the same thing right now. Rather than satellites, we're using drones, but we're once again able to see our planet from a new perspective. We're not able to just see it from the air, but we can see it often. We can see it with incredibly high resolution. We can see it with different multispectral sensors, and we can see it for free. We have democratized remote sensing. That's the big picture of what we've done here. We've democratized remote sensing. Satellites were great if you were NASA, but you didn't have access to that. You have access to a microsat in the form of a drone. And what we've seen in the history of Silicon Valley and the technology industry is time and time again, the transformative changes are not the technology, it's who uses the technology. The PC was not the first computer, nor was it the best computer, but it was the only computer you could use. And we changed the world by democratizing that. The web was not the first telecommunications network, the internet as well, but it was the first one that you could use. And we transformed broadcast, publishing, media by putting powerful tools in the hands of regular people. That's what we're doing with drones. As went the PC, as went the web, so shall go remote sensing. We are putting powerful tools in the hands of regular people. They're you, your customers, and all the other people out there who aren't in the room but will be empowered by what you do in this room. And we are the first minute of the day of seeing what they're going to do. We now have, with drones, we have a consumer application called video and photography. This is like in the PC, it launched with like word processing. But there are countless other applications that we haven't thought of. In the enterprise use, which is largely what I'm going to talk about, we haven't even scratched the surface. In 1995, you could sit down, this is about 2 years after the web was launched, but you could sit down at dinner with somebody, and you could sort of play this internet bingo. And you could say, the internet plus, and then pick a random industry, food. And by the time you got to dessert, you would have pretty much figured out a really transformative business. You would have figured out Uber and Airbnb and OpenTable. I mean, maybe not entirely figured out, but you would have gotten the broad scope Amazon of everything then. Now, it took 20 years to actually do many of these things. We needed underlying technologies like smartphones. But by and large, the moment you said internet plus traditional industry, the mind, just blew your mind because you could see the potential. We're at just this moment. You can now say drone plus, name your industry. Construction, architecture, surveying, agriculture, you name it, and transportation beyond, and then suddenly it's like, oh my God, that's the biggest big data opportunity I've ever seen. How will we make it work? And that's where we are right now. So So this is this moment where we now have a new way to sense our planet. To give you another little history lesson, in 1998, there was a massive debate about the future of wireless. And there was a new system called Iridium, which could put 64 satellites in orbit and cover the planet with satellite phones. And then, meanwhile, there was a still somewhat new technology called cell phones. And the question was, who's going to win? Why would you put 1 million cell phone towers on the ground when you could put 64 satellites in the air? Now, we know how that played out. If you understand why cell phones won, you will understand why drones will win. If you know why cell phones beat sat phones, you'll know why drones will beat satellites. Now, of course, there are still sat phones, and there will still be satellites. But the reason that the infrastructure that was small and granular and close to the ground won is because it's scaled. Is because this Iridium assumed that if everyone's going to make phone calls, that satellites are the way to do it. But the cell phones could go beyond phone calls. They could do data, and they could do broadband. And as there's a rule in economics which says supply creates demand. As you created the opportunity for people to use data while out and about, they used more of it. And Iridium could never scale to the kind of consumption of broadband data we're doing over our smartphones today. The cell network scaled, and drones scale in a way satellites don't scale. This is kind of a way to look at it. If you think of drones as being part of remote sensing broadly, so the satellites dominate remote sensing, then there's things like planes, which do a lot of remote sensing today, and then drones are small and growing. And I think what we're going to see is we're going to see a reorientation of this. We're going to see drones dominate remote sensing. Satellites are going to be number 2. And I think manned aviation as a way of gathering data is probably going to shrink, simply because it doesn't do any of the jobs particularly, any of those jobs particularly well. This is just a little bit, one of my friends is on the board of Planet Labs, which is one of these new era of satellite companies that benefits from the Elon Musk, SpaceX, and microsats, CubeSats, etc. And these guys are, as you know, transforming space, but their ambition is to take an order of magnitude, 1 factor of 10 out of the cost of space imaging. Now that's great, but drones can take 4 orders of magnitude of cost out of aerial sensing. And so the hard part is actually just finding a unit of comparison between satellites and drones. Obviously, if you want to image the entire planet, that'll be a satellite. If you want to image your backyard, that'll be a drone. And so we actually had to agree on Kansas, all of Kansas, as the sort of unit of comparison. And this is what we came up with. It turns out that it takes about the same infrastructure, the same sort of capital costs. For both, you need a constellation of about 100 satellites at $1 million each, and that's $100 million. And you also need about 200,000 drones. I mean, this is a little bit theoretical. It's, you have to sort of imagine that you're spreading these drones out there like trees. And you need about 200,000 drones to capture all of Kansas on a daily basis. Okay, so they're both, and that's also $100 million. So they're both $100 million of capital costs, so that's equal. Then let's go through the marginal costs. Maintaining satellites has a very high marginal cost. You have to get the data down, the satellites fall out of orbit every year and all that. Drones today have a non-zero marginal cost because they have operators, and one thing we'll talk about later is just how autonomy allows us to move beyond that operator model that sort of breaks the link between man and machine. And rather than one operator, one drone, it can be one operator, 200,000 drones. And so that brings the marginal cost down to 0. The resolution difference is extraordinary. It's 2 orders of magnitude, 3 centimeters per pixel versus 300 centimeters a pixel. The latency, in other words, how long it takes to get the data, is minutes versus hours. The cadence, how often you can do this is actually quite interesting. When, our company is called 3D Robotics because we took robotics to the 3rd dimension, but we could easily have been called 4D as well because time is a really interesting dimension. Being able to watch change over time, be able to take the same images every hour and then just scrub backwards and forwards through time turns out to be super useful, and drones are good at that. You can basically anywhere, anytime access to the sky. And then the final one is kind of interesting. 2/3 of the planet is under cloud cover at any point in time. That means that satellites can't see 2/3 of the planet at any given time, whereas drones are typically below the clouds, so they get 100% coverage. And that can be a really big difference when you're trying to get consistent shots over time. So that's one way to do the analysis. Another way is, sorry, let me go back here. Another way is to actually look at the cost over scale. Here you have some research that was done by an Italian academic group and then augmented by our own research. And we look at sort of two kinds of mapping. One, this is agricultural mapping. One's for 5 hectares and the other is for 50 hectares. And what's interesting is that you can, just looking at the top 3, for something like 50 hectares, satellites are much cheaper. Forgive me, I'm just looking at the top 3. Satellites are the cheapest of those options. They can cover a lot of ground quickly. You go down to 5 hectares, and drones are piloted drones are the cheapest option. And manned aircraft are kind of the worst option in all cases in this analysis. Now that was based on manned drones, in other words, operators. But when you do the same analysis and you make them autonomous, you say the drones don't have operators. Again, they're operating as fleets. It changes the dynamics tremendously. And basically, drones win at every level up to about 500 hectares. That's where those 2 lines, the blue and the red, actually cross. So this, being able to go from a remote-controlled aircraft, which is kind of what people used to think of drones, to true autonomy, where these things are unattended flying robots that can be operated as a fleet, it changes the economics to the point that you start to see that whole cell phone model winning. And this is why I think the future of drones is about using the autonomy to do something differently. Rather than treating them like manned aircraft minus the man, we can treat them like sprinklers with wings, if you will. We think of them as unattended sensors rather than piloted vehicles. I mentioned sprinklers, and that is not by coincidence. This is my grandfather, Fred Hauser. He was a Swiss immigrant in Los Angeles in the 1930s, and he invented the automatic sprinkler system. He was thank you. If you have one, you have him to thank for this. It's what happens when a Swiss engineer puts a clock on top of a sprinkler. Seems obvious now. And this was in many sense kind of a robot, right? It had it sensed time and it actuated a sprinkler, etc. But I was always influenced by this, both as an inventor and also as an entrepreneur. And so I think about sprinklers, about how sprinklers changed America. They greened the deserts, etc. But they were the first autonomy that was brought to a home. They were the first smart home element, was these automatic sprinklers. And so when I think about drones, I think about sprinklers. I think about drones not as like a box that you take somewhere, but just these boxes that are sitting out there all the time. And they just take off on their own, and they do their maps every hour, on the hour, whatever you want. They come back to their location. They charge themselves from their pads. They have these, in the same way sprinklers kind of come out of the ground and do their thing and then go back in the ground. Drones can do the same thing in little boxes that are weatherproof, etc. This is technically possible right now. You can do it with our platforms right now. Now, legally, we still have the FAA has rules about pilots in command and visual line of sight, etc. But technically, we are there. Technically, our platform supports swarming and fleets, etc. Technically, you can control a fleet of 200,000 3DR drones from a web browser 1,000 miles away. Now, it may not be feasible. Maybe those charging mats and boxes aren't commercially available yet, but it's all out there. You can see a glimpse of the way the world's going. And so when you think about drones as sprinklers, as just these little things that are out there doing their job, maybe like those traffic cameras, then you start to think about how this could scale up. The migration of drones in just the past few years has been extraordinary. We really went from the beginnings of like the flying robot. It's like, oh my God, I got this thing to fly. Then it was like, okay, but it was still very RC. It involved sticks, and you had to understand some piloting skills. And then the next step was to connect them to phones, and to make them easier to fly. And that's kind of where we are right now, and Parrot was one of the leaders, and we're doing the same thing. And the DJI and 3DR are essentially migrating almost all the functions to the smartphone, all the control functions to the smartphone. And the sticks are there when you need them, but they're not required, and many people may not use them in the future. But of course, once you've connected to the smartphone, you are intrinsically connected to the cloud. And rather than just sort of say, oh, hey, I'm connected to the cloud, we're actually now thinking about constructing these platforms as connected devices from the start, architecting drone technology as part of the Internet of Things. And when you architect from the cloud built in, you think about it differently. This is sort of the moment we found ourselves at. We saw the drones as vehicles, and that got us to about a 500,000 units. Now it's drone as cameras, and that's kind of where we are right now, which is about 1 million units. The drones as something bigger is what you guys are going to figure out. And this is going to be how we get to the tens of millions or hundreds of millions. This is how we really explore the potential of what drones can be, is by recognizing that they are part of the Internet of Things, that they are sensors connected to the Internet, and you can almost forget about the device. Imagine, they fly. Imagine they're just a sensor that magically gets itself into the air and then passes data to the cloud. Our job as an industry is to make that real, is to basically allow you to forget about the drone and to think about the data. When you do this, you realize that we are part of much bigger movements. These are sort of the buzzwords that you hear a lot in Silicon Valley: the Internet of Things, big data, reality capture, personal storytelling, the democratization of Hollywood, the video age, personal robotics, automation, the new near space race. These are all these kind of, this is buzzword bingo, but every one of these is seen as massive megatrends in Silicon Valley, and drones are plausibly part of all of them. And so, when people ask, what do you do? And you say, I work in drones, and they say, what are drones good for? You can say, whatever works. If you say the Internet of Things, you're right. If you say this is the biggest big data opportunity the world has ever seen, you're right. If you say we're part of the personal storytelling revolution, that's also right. And so that's really exciting to realize that we are not a little industry working on its own, that we are part of a bigger industry that starts with smartphones and the Internet and just takes them into the physical world. One of my favorite books when I was growing up was Flannery O'Connor's famous book of short stories. And the thing I loved most about it was the title: Everything That Rises Must Converge. Everything that rises must converge. It's poetic and beautiful, but what it really means is our job is to look at what's rising out there, look at the trends in technology, and figure out how we can use them to accelerate what we do. These are just 4 examples that we do here at 3DR. So obviously we're here largely because of smartphones. Drones were enabled by smartphone technology, the MEMS processors, the MEMS sensors, the ARM core processors, the GPS, the camera, the wireless stacks, the batteries, the incredible investment in R&D that the Apples and the Googles and the Samsungs put into smartphones have made this technology cheap and easy enough that we can now use them for drones. So thank you, smartphone industry. We are increasingly smartphones with propellers rather than airplanes minus pilots. There's Linux, which I'll talk more about, but Linux is obviously the operating system of the Internet. It's increasing the operating system of all your mobile devices, and as I'll get into it later, Linux is very much going to be driving the future of drones. ROS, you may not have heard of. It's the robot operating system. It's kind of the academic advanced robotic stuff. It has not really been appropriate for drones until recently because it's just so computationally intensive. But now drones have the processing power to be able to run ROS, and once you do that, you can tap into the extraordinary academic research on AI and computer vision, pathfinding, et cetera, that's out there, that's already in the ROS world. And so we're starting to see those worlds converging as well. And so this is really exciting. We're not just part of the drone industry anymore. We are now at the intersection of all these big industries out there, and the more we can recognize, the more we can bridge to these continents, bridge to these communities, bridge to these existing technologies, the easier our job gets. We started this by taking the largest drone software platform out there, open software platform, and platforms, and bringing them together under the Linux Foundation as something called the DRONECODE Foundation. As you can see, these are the members, and they're almost everybody out there with the exception of DJI, who's a closed source platform. And so this is like the Android this is the rebel alliance, if you will. This is everybody out there who wants to work together on open platforms, who can, as Android did, we think that there's room for both closed source and open source. It's not 100% open source, but it's an open stack, which I'll talk about in a second. But we think that the opportunity of drones is too big for any one company to do on their own. And so we created a way for lots of companies to work together to add value where they can and to have a transparent and an independent governance structure on the Linux Foundation to drive it. And we're really just getting started. But as you can see, this goes from the core technology companies like Intel and Qualcomm and Baidu. It involves big companies like Parrot. And 3DR, Unique is part of this as well. If you look at the investment out there, if you look at what these companies are doing, Unique was recently invested in by Intel. We were invested in by Qualcomm. Parrot is now porting on the APM code onto their vehicles. You can start to see all these coming together. This is becoming the new ecosystem, and I'll tell you more about what we're actually doing. But working together is the story of the 21st century. Open platforms, open innovation is the way you win. And we believe that structuring it with an independent company, an independent organization like the Linux Foundation is the way to ensure that it'll go well. When you think about what is this DRONECODE stack, it's actually an amalgamation of lots of individual projects. There's the APM and the PX4 flight code. The PX4 came from ETH, the university in Zurich. APM came from our team in the ArduPilot project originally. There's Mavlink, which is the comms stack. That's the protocol for talking to drones. There's cloud-based things like Drone Share and Drone Deploy. And then there's these development tools called DroneKit, which I'll talk a little bit more. And it's a classic stack. It looks a lot like Android. It goes from the sensor to the cloud, and it's open at every layer. Sometimes it's open source, sometimes it's open API. But this is the kind of thinking that we're all going to have to get comfortable with, because it's a complex product. This is perhaps the most complex consumer product ever made outside of a car. And the fact that it's connected to the internet and connected to the cloud means that it's got all that complexity as well. And the way we're going to be able to work with it is not by hacking in code or treating it as a drone by itself, but rather using it like the web, like web services, just standard APIs, standard web protocols that make it really easy to just get the data out of the drones or analyze the data from the drones. DroneKit is the SDK, the APIs and SDK to use this, and this is what's interesting about it. It's DroneKit.io, by the way. This is a platform that created for the Internet of Things model of drones. You can run the same code in the cloud, on the phone, or on the drone. That's really important because we don't know where the computation needs to be done. Take computer vision. You're going to be doing some computer vision on the drone. You're going to be doing some computer vision on the phone, and you can be doing some computer vision in the cloud. The one in the drone works at 1,000 hertz. The one on the phone maybe works at 10 hertz. The one in the cloud may work at 1 hertz. On the drone, you've got limited processing power. On the phone, you've got more processing power. On the cloud, you've got infinite processing power. And to be able to coordinate and distribute these computational tasks across the whole stack is exactly the way smartphones work, and it's the way drones should work as well. So any drone that you're working with right now that doesn't have a cloud API is going to miss this. Any drone that doesn't have Linux processors on board is going to miss this. And basically, this is the future of drones. They are connected, they're cloud-connected devices that allow you to distribute the computational load to whatever is appropriate, any layer of the stack. And that is what makes it a drone as opposed to an RC vehicle or toy. So I'm going to just give you a little hint that tomorrow at 1:45, Brandon Basso is going to be making an announcement about the future of DroneKit and revealing something exciting and new about that. So I'd encourage you to see his session. So just one little bit of geekery. This is the way the stack works. Is that at the core there's a black box, quite literally a black box in our case, and that's called the autopilot. And you shouldn't worry about it. It just works. DJI has an autopilot. We have an autopilot. It's just a box, and it does its thing. Now, next to that box, is another box, and that's called a companion computer. And that companion computer is typically a pretty powerful Linux processor. And that thing can do computer vision and AI and pathfinding, et cetera. There's cameras and sensors that plug into it. Obviously, you put it in a vehicle of some sort. There's all sorts of middleware and comms and things like that. There's apps on the phone. There's apps on the desktop. And then there's apps in the cloud. And then there's data analysis. But that's really what the stack looks like. And one of the questions you should ask yourself is, where do you fit? If you're a company, if you're an entrepreneur, where do you fit in the stack? Are you going to create vehicles that are innovative and serve certain needs better than others? Are you going to create apps that build on these platforms and make them appropriate for some industry that you know a lot about? Are you going to do data analysis? Are you going to come up with new sensors or cameras that can plug into this stack? But we used to worry about the flight controller, and the flight controllers are all good at this point, and they're largely done. And you can almost ignore the black box. It's like the Linux kernel. All of you have phones that have a Linux kernel or a Unix kernel in them right now. You don't worry about the Unix kernel, the Linux kernel anymore. What you worry about is either further down the stack with the sensors, the data, or further up the stack with the analysis of that data, or maybe some high-level user interface. But this is really a triumph, because we've managed to take the really hard part of controlling the things, and just basically say, that's done. I mean, ours happens to be open source, and you can modify it if you want, but you don't need to anymore. Now it's just a black box, and you can add value where it makes the most sense for you. Well, here's an example of how this gets really interesting. So as you know, safe flight has become a real challenge for us as an industry. As we've gotten better at making drones easy to use, we've lost this sort of tribal knowledge of what safe operations of aircraft is. It used to be that airplanes were hard to fly, and you had to go to a flying field, and some grizzled veteran with an AMA badge would teach you how to fly. Now a drone is something you get under the Christmas tree, and you press a button, it's up there. And so that sort of what safe flight means is not clear. And we can't expect people to read the instructions, and we can't expect people to go onto our websites, et cetera. So we need the drones to help the users be more safe. So this is an example of one application. This application, which is something we're building in both in the DRONECODE Foundation at 3DR and in an industry coalition we have called the Small UAV Coalition, we're building in what's called this Safe Flight API. And what this means is that every time that you open up your app to start your drone, it would send 4 data points to the cloud. Who are you? Some identity. What are you flying? Where are you? And when are you flying? And then the cloud would send back, to the first degree of approximation, just a red, a yellow, or a green. Red means it's the White House. You can't fly here. No, I'm not letting you take off. Green would be like, hey, you're in the middle of nowhere, go for it. And yellow might be, hey, there's something you should know about your location. It may be that you're 5 miles from an airport and you need to keep your altitude very low. It may be that you're in a residential area where they have said already that they don't want drones flying overhead. It may be that here you're fine, but 1 block over, you'd be in a national park. Or it may be that this place would normally be fine, but today there's an event, there's a parade. Or maybe there's been a fire, and there's a TFR. So that sort of educating users is going to happen through data. And that's a perfect example of where the drone talks to the cloud. The cloud has information, knowledge, and it brings that knowledge back to the user to help the user be a more responsible pilot. This is what cloud-connected devices can do, and this is going to get us out of a lot of dumb problems, which is that our drones got too smart, and they allowed what I sort of maybe inadvisedly called mass jackassery. And now, so they got too smart, so we allowed people to do things that they weren't really educated well enough to do, and now they need to get smarter yet, so we can stop them from being accidentally irresponsible, and help them be better citizens. So here's my kind of provocative statement, and I hope the technical sessions over the next couple days will defend this, but I believe that any drone that's not running Linux on board next year will be seen as a toy. And what I mean is that it's not a drone. So the definition of drone has changed over time. It used to be that anything that was flying without a pilot was a drone. And then we introduced the notion of autonomy. It had to have GPS to be a drone. And now autonomy itself also has a kind of increasing definitions. It needs scene awareness, environmental awareness, sense and avoid, computer vision, etc. True autonomy is not just following GPS waypoints. It's being able to work without GPS. It's being able to, you can follow a GPS waypoint right into a tree. That's not good enough. And so true autonomy is the kind of autonomy that you as a pilot would have, which is to say, you've got eyes and you've got a brain, and if you know what you're doing, you won't fly the drone into the tree. And so the drones need to be able to do that even better than you. And so that's what you need onboard and offboard Linux processors, but it starts with the onboard processing and the ability to have essentially smartphone-grade or better computer vision stacks running on board to do this environmental awareness, to do this scene awareness, to deliver true autonomy. Now there are some drones out there that do that right now. 3DR Solo does, the DJI Matrice does that, but that has not been the convention. And so I think what you're going to see is that it's very quickly going to be the standard, and that as you go to your technical sessions out here and talk to drone platform makers, make sure that they have this vision of really advanced computing and open stacks on board, because that's what the industry is going to need. This is what we're going to be doing with these advanced computing abilities. We're going to be doing computer vision, sense and avoid, or sense and warn, actually, which is probably more likely, because avoiding, it transfers liability to the manufacturer, but warning may not. Pathfinding using AI, not going from point A to point B, but sort of like you figure out the right way to go. Machine learning, so these things not only get smarter over time, but it can actually automatically tune themselves to platforms. With the APM project, we already auto-tune both copters and planes. You can put them in an arbitrary vehicle and it'll learn the dynamics, but we can go even further on that. We can make it so you literally can just push a button and put the box in an arbitrary vehicle, push a button, and it will figure out how to fly itself. Environmental awareness goes far beyond scene awareness. This uses every sensor we have available to us, lasers and radar and sonar and multispectral imaging. ROS, I mentioned before, the robot operating system, being able to be powerful enough to run that on board is important. Right now, our connectivity, our wireless connectivity, is either based on this old-fashioned, RC stuff, which is not truly digital, or more recently, forms of Wi-Fi or advanced digital communications like the DJI and 3DR copters. But going forward, it's clear it's going to be using something closer to LTE and 4G. Not only because you already have long-distance radios in your phone called LTE phones, but also it takes the phone out of the loop. Now the drone talks directly to the internet via the cloud, and that's going to require advanced wireless stacks. Swarming, peer-to-peer communication, so that these things operate as a fleet without the hub and spoke model we're currently in. And then finally, adaptive fail-safes. Our drones need to be not just conventional fail-safes, they need to be able to detect problems in their environment and go into some safe mode before the FAA and others will let them out there without visual line of sight. So I just wanted to end with this last, I think I've almost run out of time, but I want to end with this last note about the rest of the sessions you've got coming up. These are just some of the sessions that'll be drilling in deeper on DRONECODE projects. Some of the individual elements of DRONECODE will have technical sessions. This is going to be a good overview of the DRONECODE project today, and then some autonomous mission planning, and then Doug Wiebel from the project is going to be talking about wind estimation, which is a really interesting problem, especially on fixed wing landing, to making them as easy as the copters. Tomorrow, as I mentioned before, there'll be a drone kit announcement. And then finally, another keynote on Friday where Dan McKinnon from our team is going to be talking about agriculture, about the 3DR story where we started we started with me and my kids and Lego Mindstorms in 2007, blew my mind. I thought something has happened here, that a dad and his kids could build a drone out of Lego parts. What's going on? And here I stand years later, and I finally know what's going on. We're at the birth of a new industry. We're at the convergence of extraordinary technical planets. The fact that all of us are here today is a reflection of just how empowering these new technologies are, and I can't wait to see what you all do. Thank you very much.